Understanding unstable angina and myocardial infarction. The heart is a muscular pump located at the center of the thorax between the two lungs. It is the engine of the circulatory system. Its normal functioning is closely tied to its oxygenation. Two arteries have the crucial task of supplying the heart with oxygen. These are the coronary arteries. The left and right coronary arteries begin at the root of the aorta and lead to the heart. They split into several branches to irrigate the entire cardiac muscle. They spread into thin arterioles to cover the heart muscle and ramify into capillaries where nutrients, oxygen, and carbon dioxide are exchanged as they are everywhere else in the body. The coronary arteries, like all of the body's other arteries, are made up of three layers. The inside layer, called the intima, is like a thin layer of Teflon. It is responsible for the vessel's integrity. The thicker middle layer is made up of muscle cells. This is the media. It allows the artery to spasm, i.e., to contract and dilate. It is also the place where cholesterol plaques build up and give the arteries a yellow hue when viewed from the inside. Nitroglycerin, which is prescribed to people who suffer from angina, works to dilate the coronary arteries by acting on the cells in the muscle layer. The layer that acts as an exterior covering is called the externa or the adventitia. It is the most resistant part of the artery and serves to protect the vessel. Any change in circulation in the coronary arteries compromises the heart's oxygenation and can lead to unstable angina or a myocardial infarction. Unstable angina, now referred to as NSTEMI, is essentially a small injury to the cardiac muscle. It often foreshadows a more dangerous event, myocardial infarction, now referred to as STEMI. Known under its former name of heart attack, myocardial infarction is in fact the death of a portion of the heart. Three types of serious alterations can hinder coronary circulation. All three begin in the muscle layer, the media. 1. A spasm of the artery, either spontaneous or provoked by a substance such as cocaine. A coronary spasm is the contraction of the media's muscle layer, which strangles the vessel. The consequences of this strangling will depend on the severity of the spasm, i.e., on whether the closure of the artery is complete or partial, as well as on the spasm's duration. 2. The spontaneous dissection or tearing of the media. The cause is still not well understood, but it is thought that it could be related to an anomaly in the media. Once again, the consequences will depend on the severity of the vessel's interior tear and whether it completely or partially obstructs the inside of the artery. 3. The rupture of an atheromatous plaque, better known as cholesterol plaque. This is by far the most common cause of alteration in coronary circulation. Let us examine the third type more closely. From birth, the transportation of cholesterol leaves traces on our arterial walls. With time and age, these marks thicken on our arterial walls and eventually form plaques. The presence of cholesterol in the walls of the artery produces inflammation. The cholesterol is eaten by macrophage cells, which serve to clean the organism. They in turn fill with cholesterol and become trapped in the vessel's walls. We can picture them as large frothy cells filled with foam. When they die, they release their contents, creating even more inflammation, and the cycle repeats. The accumulation of cells and their fatty contents swells the intima, the vessel's interior layer. Rather like a pimple, the top of the plaque becomes stretched and fragile. The inflammation caused by the presence of cholesterol in the wall then activates the body's healing mechanisms. This leads to fibrosis, which takes hold and makes the plaque more rigid and firm. With time, calcium deposits can appear. Excess bad cholesterol, LDL, in the organism influences the number and size of these plaques. Moreover, some people are more predisposed to developing these plaques than others. The body's vessels distend at each heartbeat. You can observe this movement by checking your pulse in the neck or at the wrist. The coronary arteries undergo this distension while also being moved by the heart's beating. With this unrelenting movement in the coronary arteries, a cholesterol plaque can burst spontaneously. Regardless of their size, the most brittle plaques are the most likely to rupture. When a plaque ruptures, the body launches a process to fix the breach created by the rupture, beginning with the activation of blood platelets. Platelets are small particles that are found in the blood. More specifically, they are small pieces of large cells that are found in the bone marrow. They play an important role in blood coagulation, the process that stops bleeding. When we cut ourselves, we bleed. The blood runs because there is a breach in the blood vessels. The organism sets off an alarm signal, like a 911 call, to cover or close the breach. This is what coagulation does. The platelets are the first cells to enter into action. When they come into contact with elements under the fine layer of the intima, the platelets change form, produce tentacles, and stick together. They form the clot's primary structure. They also release substances that attract other platelets and activate the coagulation process by transforming certain blood proteins into small filaments. The accumulation of these filaments around platelets and trapped red blood cells forms a net that further solidifies the clot and seals the wound. The same process occurs when a cholesterol plaque creates a breach in the coronary artery by rupturing. The forming of a clot in a coronary artery can have two results: a partial obstruction or a complete obstruction of the blood vessel. Go to iCardio.ca to discover a wealth of information about heart health.